Your cat is staring at you again. Not blinking, not moving, just staring. You wave a hand near its face and the whiskers twitch before the eyes do. You've seen this 1,000 times, but you've never asked what those whiskers are actually for. The real answer is far stranger than cats have long hairs on their face. Those hairs aren't hairs at all.
Nope.
Not really. They're sensors. Living antennae, wired directly into your cat's brain, built to read the world in a way your own body can't. And once you understand how they work, you'll never look at a cat's face the same way again. Start with the basics.
Round 1.
A whisker looks like fur. It grows out of the skin like fur. But underneath the surface, it's a completely different structure. Ordinary fur sits in a simple follicle. A whisker sits in something called a follicle sinus complex.
Right.
That's a pocket filled with blood, wrapped in a dense mesh of nerve endings. Every time the whisker moves, even by a fraction of a millimeter, that fluid shifts. And that shift gets translated into an electrical signal, sent straight to the brain. Think of it like a joystick floating in a cup of water. The stick barely has to move for the water and the nerves reading it to notice. This is why a cat's whiskers are so much more sensitive than they look. A puff of air from across the room can bend one just enough to register. A change in air pressure near a wall can be enough. Your cat isn't just feeling objects it touches, it's feeling the air itself. Count them and you'll notice something else. A cat has roughly 12 whiskers on each side of its nose, arranged in neat, evenly spaced rows. That spacing isn't random. Each row sits at a slightly different height and angle, covering a wider slice of space than a single row ever could. Above the eyes, a few more whiskers stand guard, triggering an automatic blink if anything gets too close. Near the chin and the back of the front legs, still more. The whole body, not just the face, is wired for this kind of sensing. A cat walking through tall grass at night is being fed information from every direction at once, long before its eyes would ever catch a shape moving in the dark. There's also a well-known claim about whisker length, one you've probably heard before. The idea that a cat's whiskers span roughly the width of its body, giving it a built-in measuring tool for judging whether a gap is worth squeezing through. It's a satisfying idea, and it lines up with how cats behave around tight spaces. But it's worth being honest about the science here. This particular claim is more folk wisdom than settled fact, repeated so often it feels proven when it isn't fully confirmed across every cat and every body shape.
Damn!
What is confirmed is the underlying mechanism. Those forward-facing whiskers do brush the edges of an opening before the rest of the body commits, giving the cat real-time feedback on the width ahead. Whether that measurement is precisely calibrated to body size or just remarkably useful either way, the outcome looks the same from the outside. Confidence, right up until the whiskers say otherwise. Why would evolution build something so extreme? Ask a different question first. What does a predator need most, in the dark, when its eyes are nearly useless? Cats are crepuscular. That's a fancy way of saying they're built to hunt at dawn and dusk, in low light, when a mouse or a bird can barely be seen. In that kind of darkness, eyesight becomes almost irrelevant. So evolution built a second system, a tactile one that works whether or not there's a single photon of light in the room. The whiskers on a cat's cheeks, above the eyes, and near the chin form something researchers call a sensory field. Every one of those hairs works like an individual antenna, picking up a different angle of information. Together, they build something close to a 3D map of the space directly in front of the cat's face. Not a picture, a shape. A cat doesn't need to see a doorway to know it's there.
Nope.
It can feel it. And here's where it gets stranger. This same sensing trick shows up again and again across the animal kingdom, in creatures that live nowhere near each other and hunt in completely different ways. Take harbor seals. Marine biologist Guido Denhardt and his colleague Wolf Hanke studied how these animals track fish underwater in total darkness, using nothing but their whiskers. What they found was remarkable. A fish swimming through water leaves behind an invisible wake, a trail of moving water that can linger for minutes after the fish has gone. Hanker's research showed that a harbor seal can follow that wake with its whiskers alone, blindfolded, and still catch up to the exact path the fish took. The whisker itself has a rippled, undulating shape, which researchers found helps cancel out the seal's own movement through the water. So the only signal left is the fish's trail. A cat feeling the air in a dark room and a seal feeling awake in dark water are running the same basic hardware. Different environment, same idea. The uplift didn't stop with just sensing objects. It goes deeper into the brain itself. A review of vibrisal research, gathering findings from multiple neuroscience labs, found that whisker input doesn't just feed into the sensory cortex.
Nope.
It reaches into the hippocampus, the part of the brain responsible for spatial mapping and memory. Animals with damaged or removed whiskers showed changes in how neurons fired in that region, along with measurable declines in navigational ability. In other words, whiskers aren't just for feeling what's nearby. They help build the internal map of where an animal is and where it's been. Take away the whiskers, and the map gets worse. Pause on that for a second. Your cat isn't just using its whiskers to avoid bumping into furniture.
Nope.
It's using them to understand where it exists in space, the same way you use your eyes and your inner ear together to know which way is up.
Yeah!
This system starts working almost immediately after birth.
Damn.
Kittens open their eyes days after being born, but their whiskers are already functional, still developing, but already sending signals. Before a kitten can see its mother clearly, it can already feel her. That's how a newborn kitten, blind and unsteady, manages to find its way back to a nursing spot in a pile of littermates. Not by sight,
Nope.
by touch, guided by a system that was online before vision even had the chance to matter. Nature rarely builds redundant systems for no reason. When it activates the whiskers first, that's a signal about which sense it considers more urgent to survival. So what happens when a cat loses that system, even briefly? Watch a cat with wet, matted whiskers, or one recovering from a vet visit where they were accidentally bent back. It moves differently, more cautiously. It hesitates at doorways it normally walks through without a thought. It's not being dramatic. Its map just got fuzzy. This is also why cats are famously reluctant to eat from a deep, narrow bowl. Every time the whiskers press against the sides, the cat's brain interprets that as unexpected contact, sometimes uncomfortable, sometimes genuinely stressful, depending on the individual. Veterinary behaviorists have documented this reluctance closely enough that it now has an informal name: whisker stress. It's still being studied and isn't universal across every cat, but the underlying mechanism lines up perfectly with everything else you now know. A structure built to detect the faintest touch is not going to enjoy being pressed against plastic 30 times a minute.
Nope.
Here's the part almost nobody notices. Whiskers don't just receive information, they also broadcast it. Watch a cat approach something new. The whiskers push forward, spreading wide, angling toward the object like a satellite dish adjusting its aim. That's the sensing side at work, gathering as much surface area as possible. Now watch a cat that's frightened, or in pain, or trying to seem small. The whiskers pull back flat against the face. That's not an accident either. It's partly protective, keeping delicate sensors out of the way of a possible threat, and partly a visible signal to any other cat watching. Ears back, whiskers back, body low. Anyone reading that face, animal or human, gets the message instantly, without a single sound.
Nada.
So the same structure that reads the world in complete darkness is also, in daylight, quietly telling you and every other creature nearby exactly how your cat feels.
Damn.
There's a middle position too,
One you've probably seen without naming it. Whiskers held loosely to the side, neither pushed forward nor pinned back. That's the resting state, the equivalent of a relaxed, neutral face. It's the baseline your cat returns to the moment a threat passes or curiosity fades. Learn to spot that neutral position, and the forward and backward extremes start to mean something. You stop just seeing a cat's face. You start reading it. The same way you'd read a raised eyebrow or a clenched jaw on a person. Except this signal was never meant for you at all. It evolved for reading between cats, long before any cat ever shared a couch with a human.
Damn!
None of this stayed confined to biology labs. In 2025, a team of material scientists led by researcher Dan Scher built a synthetic sensor modeled directly on the structure of a cat's whisker and its follicle sinus complex. Published in the journal Advanced Functional Materials, their design used flexible fiber material to mimic how a whisker amplifies tiny mechanical signals into something a nervous system, or in this case, a machine, can detect. The resulting sensor could register pressure changes as small as a gentle human sport movement, at a response time measured in milliseconds. An engineering team, centuries after cats evolved this system for hunting in the dark, looked at a whisker and thought, we should be copying this.
Damn!
Which raises the real question underneath all of it. How much of what looks ordinary is actually engineering you've simply stopped noticing? You reach for your phone in a dark room without looking, guided by touch alone. You know when someone's standing close behind you before you turn around, from a change in air movement you never consciously register. You feel your way along a wall in the dark. None of that is whiskers. Humans don't have them. But the impulse behind it, tuning a body to sense what the eyes can't reach, is the same evolutionary pressure that built the structure sitting on your cat's face right now.
Evolution complete.
Every stare, every twitch, every cautious pause at a doorway is a live readout from one of the most sensitive touch systems any land animal has ever evolved.
Damn!
It was never just decoration.
Nope.
It was never just fur.
Nope.
It's a map-making, wake-tracking, mood-broadcasting sensory organ, sitting quietly on a face that spends most of its day asleep on your couch. So the next time your cat stares at you, unmoving, whiskers angled forward, remember what's actually happening. It isn't just looking at you. It's reading the room in a language your body doesn't speak. And the real answer to that stare was never as simple as it looked.